for you all to try this and get the proof. So now we will move on to the next beautiful question. The question is, if I suffix n is equal to integral cot raised to the power of n x dx and I suffix 0 positive I suffix 1 positive 2 times of I suffix 2 positive I suffix 3 positive etc. up unto I suffix 8 followed by I suffix 9 positive I suffix 10 is equal to a times of u positive u squared over 2 positive etc. up unto positive c, then we are asked to get the value of a. Now where our u is given to be as cot x and c is the arbitrary constant. So this is a beautiful question. Now the most important thing is we have a relationship connecting I and cot, right? So that relationship is, we know that I suffix n positive I suffix n negative 2 is equal to negative of cot raised to the power of n negative 1 x divided by n negative 1, right? This relationship can be rewritten as negative of cot x raised to the power of n negative 1 divided by n negative 1, right? But we are given that u is equal to cot x, so I can rewrite this as negative u raised to the power of n negative 1 divided by n negative 1, and of course on the left hand side I got I suffix n positive I suffix n negative 2. So this is what we are going to use. Now we have got, this is given, I0 positive I1 positive 2 times I2 and so on. Now let me write that down. So given I0 positive I1 positive 2 times of I2. So the meaning is I2 occurs twice. So let me write that I2 positive I2 positive I3 occurs twice, I3 positive I4 positive I4 positive I5 positive I5 positive I6 positive I6 positive I7 positive I7 positive I8 positive I8 positive I9 positive I10 is equal to, of course I am not considering the right hand side, it's understood, the right hand side is featured there. So let me simplify this, is equal to the right hand side, it's given. So let me just place it in the actually, since the space is too limited, I just want to just place RHS there. Now what I want to do is I want to club these terms. So that clubbing is done as follows. So what I would do is I would take I0 with I2. I0 is added with I2, that's fine. Then I will add I1 with I3. In other words, probably this would be a better way, I1 with I3, okay? And now I've got I2, I would add this I2 with I4. So I2 positive I4. Now I got I3, I will add this I3 with I5. So I3 plus I5, so that's fine. Now I got I4 with I6, so I will add I4 with I6, that's fine. Now I got I5, I will add I5 with I7, so this goes with this, so I5 with I7, right? Now I got I6, I will add it with I8, I6 and I8, and then so I4 with I6, that's fine, and I5 and I7, and I6 with I8. Okay, so this is done, this is done. I got a I7, so we need to have two I7s, right? So I've just placed one I7, so two I7s are there. So now I8 is over here, so one I7 is there. So I will just add this I7 with I9, right? So that's going to be plus I7 with I9, that's fine, and I get a I8 and a I10, so I will add I8 with I10, so that's fair enough, and this is equal to the right hand side. Now we will have to evaluate this. So how are we going to evaluate this? We are going to use this expansion, or I would say this expression, this equation which we have got. So let me name it as 2. Now if I were to substitute I0, right, in fact to get I0 I need to substitute n is equal to 2. So that would give me the first term. So now the thing is that I need to move on to the next page so that you can better understand what we are doing. So let's do that. So I'm going to take n is equal to 2. Now if n is equal to 2, this would give me I2 positive, n is equal to 2, that's going to be I0. This is equal to, I need to substitute n is equal to 2, so it's going to be negative u raised to the power of 2 negative 1 divided by 2 negative 1, which is equal to negative u raised to the power of 1 divided by 1, which is nothing but negative u. So that's fine. I've got I0 positive I2. So next is I1 positive I3. So when would that be possible? To get I1, I would have to take n is equal to 3. So this is n is equal to 2. This is n is equal to 3. If I were to take n is equal to 3, this is going to be negative u 3 negative 1, right? So that's going to be u squared divided by 3 negative 1 is equal to 2, which is equal to negative u squared over 2. Next, n is equal to 4. N is equal to 4 would give me I4 negative 2 would give me I2, and this is 4. So this is I2 and I4, and n is equal to 4 is going to be negative u raised to the power of 3. 3 negative 1 is going to be 2, so this is negative u cubed over 2. So this is what I've got. Next, n is equal to 5. If I were to take n is equal to 5, I would get I3 positive I5 and negative of u4 divided by 5. 5 negative 1 is 4, so this is negative u raised to the power of 4 divided by 4. So next, n is equal to 6. 6 would give me 4 here, and I6, so n is equal to 6 would give me 5 and 5, so negative u raised to the power of 5 divided by 5. Now n is equal to 7. Let me use the space here, and that would give me I5 positive I7 is equal to negative u6 divided by 6. N is equal to 8. N is equal to 8 would give me I6 positive I8 is equal to negative u7 divided by 7, and n is equal to 9 would give me 7 positive I9, which is equal to 9 means negative u8 divided by 8, right? So next is n is equal to 10. N is equal to 10 would give me I8 positive I10 is equal to n is equal to 10, that's going to be negative u9 divided by 9. So we got a value for this, 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 for this. So let's substitute that. So if I were to take this as 3, right, so taking this as 3, right, this would give me 3 would now be rewritten as Therefore 3 is re-returned as. Substitute these values. So this is going to be negative u squared over 2 negative u cubed over 2, right? N is equal to 3, 3 minus 2, n is equal to 4. This would be 3 here. Okay, just a small correction. This is going to be 3. Okay, so u cubed over 3 and followed by negative u4 over 4, negative u5 over 5, negative u6 over 6, negative u7 over 7, negative u8 over 8, negative u9 over 9. Right. So if I were to take the negative sign out, I'm going to take the negative sign out. This would give me u positive u squared over 2, positive u cubed over 3, positive u4 over 4, positive u5 over 5, positive u6 over 6, positive u7 over 7, positive u8 over 8, positive u9 over 9. So this is what I have got. So taking negative 1, now if we were to equate this with the right hand side, so this is equal to, so let me write that down, equating with the right hand side. So what is on the right hand side? The right hand side is actually a times of u positive u squared over 2 positive u cubed over 3 plus etc. u raised to the power of 9 over 9. This is the right hand side. So clearly equating this quantity with the right hand side would give us a is equal to negative 1. So that is the solution for this particular question. Thank you students. I hope you enjoyed this particular lecture and we will meet you all in the next lecture. Have a nice day.